Okay, so the whole point of this assignment, if you were gone or you missed, wasn't the houses and the bunk beds and the floors of the building. The whole point of this whole entire assignment is how the electrons fill up the space. You all know how to write an electron configuration. We did that last week. So you know how to do the 1s2, 2s2, 2p2, 2p6, and so forth. But it's the whole important part of this assignment was how the electrons actually fill up. Okay? So I'm going to go through this, what we did today, so you have it if you're absent, or you just need to watch it again. So examine the boarding houses above, match each symbol below with its most likely meaning. Right? Well, those dots, right, are the people staying there, the boarders. But let's make it relatable to what we've been doing. Those borders are going to represent electrons. Okay, so while I'm doing this, you should be adding notes to yours. When I see those additional notes, I know you paid attention and you were watching the video, and then I can grade it, give you full credit for it. Okay, those little, they look like ladders, but they're the bunk beds for borders. That's one. And those bunk beds represent orbitals. Every orbital can hold 2 electrons, right? Every bunk bed can hold 2 people. And then C is the manager's code for the borders, and we know what that is. That is an electron configuration. Okay, I want you all to also take a peek at some of these things. You notice that the rooms on the left-hand side right here, they're called the sunny rooms, and they start with S. So what do you think that relates to? Probably the S block, right? And we know every S block can only hold up to 2 electrons. Why? There's only 2 columns in the S block. Okay, or 2 groups. And then you notice over here, oh, that's funny. The P rooms, or the pink rooms, start on the 2nd level, right? And then go to the 3rd and so forth. But P probably represents what? The P block. And we know the P block can hold a total of 6 electrons, or 6 columns, 2, 4, 6. Okay, it's just some little things like how it relates to what we've been doing. Okay, so number 2 says refer to model 1, so this picture right here, and it says, I'm going to try and split it so you can kind of see both. It says how many boarders were in the boarding house at 5 p.m. So we're looking at this one, 5 o'clock. Okay, the borders represent, right, they're represented by the dots, and those to us are electrons. Okay, how many are there? 2, 4, 6, 8. There are 8 electrons. Okay, how did you determine it? There are multiple ways. You could have counted them. You could have looked at the electron configuration. You could have looked at the number that oxygen is, or sorry, just kidding. Those are the 2. You could have counted from the electron configuration or the address, or counted the dots. Okay. 3. Each diagram in Model 1 and the corresponding manager's code. Using the following manager's code, underline the floor numbers. Your floor numbers, right? The first floor, second floor. And those represent your energy levels. Right, we talked about energy levels last Thursday, those rings around the nucleus, okay? Circle the type of rooms, right? We have sunny rooms and the pink rooms. So we have sunny and pink rooms. Those represent our sublevels, or, right, our specific blocks. The S, the P, the D, and the F. Okay? And our last one, let me see here. Draw a box around the numbers of borders, or numbers of electrons, remember? Our exponents. Those are the electrons. So the number of borders are our number of electrons. in each sublevel. All right, number 4. The manager of the boarding house has some very strict rules on how beds will be rented out for the night. Examine the diagram in Model 1 and the statements below to determine the phrase that best describes the manager's set of rules. Circle the correct answer. Okay. A. The boarding house will rent out beds on the what floor first? Well, if you take a peek at like 1 o'clock to 2, right? Or at 1 o'clock specifically, they didn't rent out anything on the second floor, so the first floor. Boarders are allowed to double up in a bunk in a room when there's an even number of boarders or all the bunks are occupied. And that should make sense, right? You don't want to double up with somebody on a bunk bed if there's a free bunk bed. You're going to go take that one. Okay, and this rule will come into play later. And this one. These are all important rules for later. The next floor of rooms will be open for boarders only when all of your bunks on the floor are occupied. All of these rules are going to be relatable to electron configuration and where they're placed. Okay, D. The pink room on a floor will be open for boarders only when. Let's see which one's a good example for that. I think 9 p.m. shows it well. You have, right, this is filled and then they added one to the pink room on the 3rd floor, so they won't add one to here until that is filled up. Okay, so the answer for D would be when all the bunks in the sunny room on that floor are occupied. All right, 5. Provide the manager's code, aka the electron configuration, and the boarding house diagram. We're going to change this up. Okay, I'm going to draw something different for 12 boarders or, right, 12 electrons. Okay, so we should be able to do an electron configuration for 12 electrons. So you should have got 1s2, 2s2, 2p6, and 3s2. How can I check my exponents? Do they add up to 12? 2 plus 2 is 4, plus 6 is 10, plus 2 is 12. So, and we're in the right order. Okay, I want you to draw this, even if you already drew your house model somewhere. Draw a little line, label it 1s, 2s, and then 3 lines or orbitals for 2p, and then 3s, right? And then there'd be 1, 2, 3p. Kind of looks like the floors, right? 1s, 2nd energy level, 3rd energy level. So we're going to fill up with 12 electrons. Pay attention to the way I fill the electrons, and I'm not going to use dots, I'm going to use arrows. I filled up my first room. I filled up my second room. There's only one bunk. In the P sublevel, you have to fill up every bunk first, then you double up. Okay, and then I have 2 electrons there, or 2 arrows, and those should add up to 12. I have 2, 4, 6, 8, 10, 12. Okay, and this is going to come into play on this next page. All right. Number 6, right, using the above diagrams, those boxes, or I used lines on the previous, that represents an orbital. So that's 3. Think about it, if an orbital can hold 2 electrons, there should only be 1 orbital in the S, right? 3 orbitals in the P, because the P can hold 6. There would be 5 orbitals in the D and 7 in the F. 1 arrow represents a single electron. 2 arrows represents a pair. 3 of those, right? If you have 3 orbitals, that would represent a sublevel, and specifically the P sublevel, right? It looks something like that. That would be the P sublevel. And then 1s, 2s, 2p4 would be the electron configuration. Okay. If at any point you're like, I'm still confused about something, make sure you come in and you ask about that specific thing you're confused about. All right, number 7, consider the orbital diagram for oxygen. Try and squeeze it over. There's oxygen. How many electrons are present in the orbital? Well, our electrons are the arrows. We have 1, 2, 3, 4, 5, 6, 7, 8. And you know, oxygen is number 8 on the periodic table. So based on its position in the periodic table, explain how you know that your answer to part A is correct. Well, if oxygen's number 8 on the periodic table, we know the atomic number equals the number of protons. And since we're dealing with neutral atoms, we know the number of protons equals our number of electrons. So there should be 8. All right, we're not going to do 8 because we already did 8 on the front side of the page for number 3. So that's already done. We already talked about that. Okay, number 9, you have 2s, 2p sublevels are very close in energy, as are the 3s and 3p. Explain how the orbital diagram for sodium confirms that the 3s sublevel is lower in energy than the 3p. I really want you to take a peek over here. See this? It says the energy is increasing. So as you fill these orbitals and sublevels, those electrons are gaining energy. They have more energy. The further you are from the nucleus, the more energy those electrons have. So if you think about it, for number 9, the 3s, right, is slightly below the 3p, right? So the 3s has less energy than the 3p. So it's just asking you that question so that you understand what energy levels have more energy, right? Well, the 1s has the least amount of energy, then 2, and p. Or you can think of it the other way, right? 3p has the most. As you continue up, they gain energy. All right, numbers 10, 11, or 12 are the most important, okay? And this is how we fill those arrows and electrons, okay? So lowest potential energy arrangement is how we fill them. It is called the ground state. So however we typically fill them, that's the ground state normal. Ground state electron configurations can be predicted by a strict set of rules. You need to know these rules. The first one is known as off-bow principle, meaning filling up. Examine each diagram in Model 2 and the statements below to determine the phrase that best describes each rule. Circle the correct answer. So based on where a single electron is placed, the lowest energy level electron in an atom is found in the, we always start at the lowest energy level, 1s. So you don't get to say, oh, I'm going to start filling electrons in 2s or 3s. You always start at 1 and work your way up. Electrons will occupy a p orbital only after, well, think about those rooms on the other page. We don't get to go to the p until your s orbital is completely full. Okay, so think about it this way. I have 1s, I have 2s, and I have 2p. Right? I don't get to go to that 2p until this is filled. Right? Once that's filled, then you can start filling electrons. All right, C, electrons can begin to occupy energy levels with the next highest integer. So, right, when we would go to like the 3s, only after blank on the energy level below it are occupied. So it wants all of the orbitals below. So I don't get to move on to the 3 until all of my 2s and 2p are filled. You don't get to go, I'm going to go 3s, 2, and then go jump that. You don't get to skip that, okay? And those are all off-bows rules. All right, 2 more rules and then we're done. All right, so 11 and 12, 10, 11, 12, super important, okay? So that second rule is Pauli exclusion. It describes the restriction on the placement of electrons into the same orbital. Pauli exclusion principle can be expressed as if 2 two electrons occupy the same orbital, they need to have opposite spins. Meaning, when you fill, like the 1s, you cannot fill them with both the arrows going up. Not good, okay? So it should look like with one arrow up and one arrow down for the 1s. That's the correct way. All right, Hund's rule states, describe how the electrons are distributed among orbitals of the same sublevel when there are more than one way to distribute them. Hund's rule consists of two important ideas. Okay, so you need to be familiar with both of these. Based on Model 2, circle the correct answer. Electrons will pair up in an orbital only when. Think about it. They don't double up on a bunk bed until all the beds are filled. So electrons will pair up in an orbital only when all the orbitals in the same sublevel have one electron. Meaning, I have 1s, 2s, and then we'll write it right here, 2p, you do not get to do, you don't get to double up there. That is not okay. What it should look like, 1s, 2s, 2p, right? You should have these filled, and then you should single, single. You don't get to double up until all three are filled. And remember, those arrows are all based on the number of electrons you have. When single electrons occupy different orbitals of the same level, they all need to have the same spin. So if I'm filling up the 2p, I don't get to go, I feel like doing one arrow up and one arrow down and then the other one up, okay? So that's not okay. It needs to, they all need to go up, okay? I'm not gonna go over number 13. You really need to know 10, 11, 12, that's part of your homework, okay? 14, we did in class, we talked about the errors, are they correct or wrong? So you should be able to look at these diagrams and identify the error, if there is one. Okay, so for example in 14a, you don't get to skip a level, right? They didn't fill that sublevel before moving on. That violates the off-bow rule, okay? And the other thing that's wrong with this is if we're doing nitrogen, we should have 7 electrons. There's only 1, 2, 3, 4, 5, 6. But the big one is the rule that it broke. Okay, second one, they doubled up, then they filled that one, and then they filled those up. Okay, they can go down first. They're all in the same direction, so this is correct. Okay, C, we doubled up, and we doubled up here without filling every bunk or orbital first. So really it should look like this, up, up, and up. They doubled up, and that is a violation of Hund's rule. Okay? So for practice, make sure that you can fill in the orbitals correctly with the number of electrons. So for example, sulfur is number 18. It's 18 electrons. Okay? You should definitely be able to do an electron configuration. And then pay attention to filling, right? We start here, double, 1, 2, double, single, 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 double, double, double. Let me see, I lost count. We're at 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? All right, hopefully that helps, and if you have any questions, you can come in and see me, and you need this assignment to be able to do your homework.